Hello, hi everyone. Welcome back to the NCERT classes. So we were doing the number system. We have done up to chapter 1.2. Now we are doing chapter 1.3. So this is NCERT class 9 book. You can see much familiar with the book. So now what is in the chapter 1.3? We will first discuss the concept, then we will solve the questions. So this is very important and interesting also. So let's move forward, and I request, if you like the video, if you like the content, do like the channel, subscribe the channel, do like the video. So now these are just all written by me. It's a pure cursive, so I hope the students studying in CBSE will be able to understand, because they do have to write the cursive. But no problem, I will just read it out for you, so no problem in understanding. Now, what real numbers and their decimal expansion? So we will learn real numbers and their decimal expansion, and how to distinguish between rational and irrational numbers by looking at the decimal expansion. And so in this section we will look at decimal expansion of rational numbers, like how to expand the rational numbers in decimal form, and see if we can use the expansion to distinguish between rationals and irrationals. So if the number is given, you can distinguish between if this is rational or irrational, or if you have to expand the given number as a rational or irrational. So now we'll just see with the example. Find the decimal expansion of 10 by 3, 7 by 8 and 1 by 7. So for the simplicity, I have done the division. So 10 by 3, this is the divisor, this is the dividend, this is the quotient, and these are the remainders. So I hope you are much familiar with this divisor, dividend, and this is called the quotient. And what we get here is called the remainder after dividing. Okay, so when you divide 10 by 3, you will get 3 times 3 9, 1 as remainder, then you get 0 9 1 as remainder. So this is long going number. Remainder here is 1 and divisor here is 3. So you will keep on dividing. It will not reach to any conclusion, mean any, it will not terminate, it will just recur. And what is the recurring? 3 is the recurring number. Now you see 7 by 8. If you divide 7 by 8, it will not divide, you have to use 0 point, then 8 8 64, remainder 6, 8 7 56, remainder 5 40. So here remainder is 0, and the division is, you see, it is terminating. It's 875.875. It not goes beyond this, or not, it's not repeating. So just keep on listening what I'm trying to say. When you do 10, when you divide 10 by 7, 1 by 7, sorry, it is 1 by 7. You put point, you put 0 here, divide here, remainder is first time it's come 3, put 0, 7 4 28, here come remainder 2, again here come remainder 6. You see the remainders are changing in this case, 3 2 6. Now here comes 4, here comes 5, again 1 4 2 8 5 7. If you divide further, so here what you see, you started 1, dividing 1 with 7, and again it is coming 1 with 7. Understood? So if you go on dividing, it will again come 0.142857, again up, again 0.142857. So this part will repeat itself in dividing, it will not terminate. So here remainders are 6, 4, 0, and divisor is it. Here remainders are 3, 2, 6, 4, 5, 1, 3, 2, 6, 4, 5, 1. It will go on repeating itself. Here divisor 7. You see how many in quotient, how many digits are there? 1, 2, 3, 4, 5, 6. And what is the divisor? 7. So when the remainders are not repeating, means it's 3, 2, 6, then divisor will be less than your uh, quotient will be less than your divisor. Okay, in this also, if it is repeating only one times, so it will be only one of the digit will be repeating. So I hope you are getting. Okay, so now what are the points to be noted from the above three examples? So what you have seen, the remainders either become zero after a certain stage or start repeating themselves. So you can see in this case remainder becomes zero, and in this case it will start repeating, itself, like first 3, 2, 6, 4, 5. Again if you go on, it will repeat 3, 2, 6, 4, 5. In this case also remainders repeating 1, 1, 1. So first this we have checked. Okay, now the number of entries in the repeating string of remainder is less than the divisor. So what this shows, the number of entries in the repeating string. So this is the repeating string. This is less than the divisor. So divisor is 7, and you see the repeating string is 6. So this is also noted that repeating string is less than the divisor. Again here you see repeating string is 3, 3, 3. Only one digit repeating, and it is less than the divisor. It is not said that it is 1 less than the divisor. It will only less than the divisor. Divisor is 3 and repeating string is 1 here. Means only one digit is repeating. If the remainders repeat, okay, then we get a repeating block of digit in the quotient. Okay, so if the remainders repeat, in this case only the remainders are repeating 1, 1, 1, 1. So what we get? We get a repeating block of digits in the quotient. So we are getting a repeating block of digits. Only three is continuously repeating itself. If the remainders do not repeat, we will get certain number of digits after it start repeating itself. Like, and that will be less than the divisor. So hope you are getting it also. Now this pattern is true for all rationals of the form P by Q. So what a pattern we saw in the previous three examples will be true for all rationals in the form of P by Q and Q not equal to 0. So this we know is the rational numbers property. Now on division of P by Q, two main things happen. So what we saw earlier is written here. Either the remainder becomes 0 or never becomes 0, and we get a repeating string of remainders. So what we saw in one example, remainder becomes 0, and in other two examples never becomes 0, and we get a repeating string of remainders. Now we'll see the first case. Case 1, the remainder becomes 0. We'll see some examples of this, like 7 by 8. If you divide, you have seen in the principle, so it's terminating. Remainder becomes 0 and your quotient ends here. 1 by 2, if you divide, remainder becomes 0, it will be 0.5. If you divide this, the remainder becomes 0, and this is how it will terminate. 2.556 will be the answer. So the remainder becomes 0 after certain steps. This expansion of number is called terminating. So why it is repeating the word? because this will come in chapter multiple times. Means remainder becomes 0. If remainder becomes 0, there will be nothing to divide. So the quotient will be terminating. Once your the expansion will be terminating. It terminates here only. There is nothing after that. It terminates here only. It terminates here only. So this is called terminating. Like it ends here. Now, when the remainder doesn't become 0, case 2 the remainder never becomes 0. Like 10 by 3, 3.333 dot 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 333, 1 by 7. So if you divide 1 by 7, you will see this part will repeat 142,857, 142,857, 142,857. This will go on. Now to sum up the repeating part, we use the term bar. We keep a bar which is repeating itself. So in 3.33 we keep a bar over 3. So the the number over whom the bar is placed, only that number will repeat. So in this case only 3 will repeat. Like if we put bar here, 142,857, whole this will repeat. If something like 3.472, 3.472, this, so 472 will repeat again and again and again. So this is the meaning of bar, that if it is placed over the number, that number is a repeating, it is non-terminating. So these are examples of non-terminating and recurring. Recurring means repeating. So now you will come to the definition of rational numbers. Thus, we see that the decimal expansion of rational numbers have only two choices. Either they are terminating or non-terminating recurring. So this you have to remember. Either they are terminating, means remainder will become 0 and your expansion will terminate. Or it will be non-terminating and recurring. Like the remainders keep on repeating up, and your division will not terminate. It will just recur after some numbers. So we will see some examples that will be more clear. So that this 3.1142,678 is a rational number. In other words, expressed in the form of P by Q. So this is terminating 678. There is no bar, nothing is placed over it. So this is terminating, and they have asked, it has asked to express in the form of P by Q. So simple, what we do, we just remove this point, put 1 and 0. The number of digits after this point, we keep the same number of zeros. 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6. Hence this is a rational numbers. This is P and this is Q. So this is very simple. Now we'll move to next question. Now show that 0.333 is equal to 0.3 bar. You can write this can be expressed in the form of P by Q, where P and Q are integers and Q not equal to 0. So you simply consider, since we don't know what is the value of 0.3 bar, so we consider 0.333x x, or x is equal to 0.333 or 0.3 bar, anything you can write. Since only one digit is repeating, see only 3 is repeating because it has placed bar on only 3. So we multiply by x. Take this as equation 1. Okay. Now we multiply by 10. So 10x is equals to 0.333 into 10, or 10x is equal to 3.333. Take this as equation 2. Now either you split it into two numbers or you just subtract. So this is the most easy number. Subtract 1 from 2. So 10x less x is equals to 3.333 less 0.333. 9x is equals to 3. X is equals to 3 by 9, or x is equals to 1 by 3. So again, this is in the form of p by q, and here q is not equals to 0. So either you can split 3.3 can be split as 3 plus 0.333. 0.333 is x, or you can do it by subtraction. Take the first as equation 1 and this as equation 2 and just solve. Now show that 1.272727 is equal to 1.27 can be expressed in the form of p by q. Again 1.27 is 0.27 is repeating here, 2727. So we will keep a bar on 27. Now again let x is equal to 1.272727 or 1.27 bar simply. Now since two digits are repeating here, 27 is repeating, so multiply both side by 100, or you take this digit as 1 and multiply by 100. Then 100, if you multiply by 100, this point will shift to here, 10 for this and 10 for this. Now again you take this as equation 2. Now again subtract. So 100x less x is equals to, what is 100x? 127.27. 127.27 less 1.27. So 99x is equals to, if we do 126, x is equals to 126 by 99. So 9 times 9, 11, 14. So 14 by 11 is equals to p by q, and q not equals to 0. So either you, because this is for better understanding, you keep this method only. Sorry. So for better understanding, you keep this method only. So what is happening? Okay. Subtract the second equation, first equation by the second equation, you will get the answer. Now 0.2353535. So here 0.2 is not repeating. After that 35353535 is repeating. So it will be 0.235 bar. So again, since two digits are repeating, we will multiply. This is the first equation, and this is will be our second equation. Multiply by 100. Now again subtract. 100x less x is equals to 23.53 minus 0.235. So 99x will be 23.3. Simply if you check also now, 23.53 less 0.253, 0.235, 0.2, so 0.3, 23.3. So x is equals to 23.3 by 99, or x is equals to 233 by 990. So since you are class 9, you will be understanding this all divisions. So again it is the form of p by q, and here q is not equal to 0. So these are all, means these are all rational numbers. Okay. Now moving on to the next question. Next. So we will came to know that what are rational numbers. So the decimal expansion of rational number is either terminating or it is non-terminating recurring. Yes, your quotient recur or remainders never comes to zero. No, a decimal expansion of a rational number are either terminating or non-terminating recurring. Moreover, a number whose decimal expansion is terminating or non-terminating recurring is rational. Again, this is the same thing. If you are given any decimal expansion and you have to identify, so you can check it is terminating or non-terminating recurring. So keep this point in mind: terminating and non-terminating but recurring. So that is the rational numbers. Now for irrational numbers we will say. So we know root 2 is irrational number. So expansion of root 2 is 1.414213. So and pi is also irrational number. We have seen earlier 3.141592653. So this is expansion. We take pi is equal to 22 by 7 generally in our solution, or 3.14 as an approx value, not the exact value. Just to get to a solution, we take this value. So the decimal expansion of an irrational number is non-terminating and non-recurring. So you say this is non-terminating and is also non-recurring. None of the part is repeating itself. 1415926335897. So the decimal expansion of an irrational number is non-terminating, non-recurring. Again, a number whose decimal expansion is non-terminating, non-recurring is irrational. So these are two definitions of rational and irrational numbers. Now find an irrational number between 1 by 7 and 2 by 7. So we know that there also we have seen that there are indefinitely many rational and irrational number between two numbers. But again we have to solve this. So we know the value of 1 by 7. You can divide and get the value of. Now how to get 2 by 7? So this is a 2 times of this value. So multiply this by 2. You will get this value. Now take a known rational number like 1.414 root 2. Divide it by a number to bring it to a required range. So we need to find between these two, 0.14 and 0.28. We know root 2 is 1.4. So if we'll divide by 10, it will come to 0.14. So this is less than this. And if we divide it by 5, we'll get 0.28. So 0.28 is a rational number. So 2828 is not, this is also not terminating. It will also come much more numbers. So root 2 by 5 is a irrational number because it lies between these two values, 0.14 and 0.28. You can find any other number also. Now we'll go to the exercise. This is 1.3. Now what is given in the first question? Write the following in decimal form and say what kind of decimal expansion each has. 36 by 100. So you can write 0.36. So this is terminating. So this is terminating decimal. Only write this part. Okay. Now 1 by 11. So you see, if you divide, no need to divide for you. You are smart enough to divide by yourself. So it will come 0.09, So this is non-terminating recurring decimal. Okay. And what is recurring? 0.9 is recurring. You can write is 0.09 bar also because 0.9 is recurring. So it's non-terminating but recurring decimal. 41 by 8. 33 by 8. So 4.125. This is terminating decimal. 3 by 13. If you divide, it will come 0.23076923007. So this part will repeat. Non-terminating recurring. Again, this point will repeat. 0.2307692307692300769. So it is not terminate. It will not terminate at any point, but it will recur. Now, 2 by 11.181818. This is also non-terminating recurring, and 0.18 is repeating or recurring itself. 329 by 400. This will come to 0.8225. So this is terminating. Anything whose remainders come to 0 is terminating. Now you know that 1 by 7 is equals to this. Can you predict what the decimal expansion of 2 by 7 and 3 by 7? Simply multiply. This is 2 times of 1 by 7. 2 by 7 is what? 2 times of 1 by 7. 2 into 1 by 7. So multiply the value of, without actually doing the long division. Yes, simply multiply it. 2 by 1 by 7 point. So multiply 142,857 into 2, 4, 11, 1, 6, sorry, 7, 5, 8, 2, 285,714. This is 2 by 7. Similarly, 3 by 7 multiplied by 3, 4 by 7 multiplied by 4, 5 by 7 multiplied by 5, 6 by 7 multiplied by 6. So this is how you can do without actually doing the division. You see, this is 4 times 1 by 7, 5 times 1 by 7. So there is no harm in multiplying directly. Now question 3. Express the following in the form of P by Q, where P by Q are integers. 0.6 bar. Okay. Bar means only 6 is repeating. It will be 6, 6, 6, 6. Okay. So only 6 will be repeating. Multiplied by 10. So let x is equals to, this is our first equation, and multiply by 10, this is our second equation. We will solve, subtract 1 from 2. Keep the habit of writing this. I can directly solve this also, but in your exams, your marks will be deducted if you don't write this line. Subtract 1 from 2, because you should know what to be subtracted and from whom to be subtracted. From means, from this will be subtracted. So 10x less x is equals to 6.66 less 0.6. 9x is equals to 6. 0.66 will be subtracted. X is equals to 6 by 9. X is equals to 2 by 3. So this is P and this is Q, which is in the form of P by Q, where Q is not equals to 0. So better go with this approach. We will go with this approach only in the other sums. Now here point x is equal to 0.47 bar, only one digit is repeating. Okay, so we'll multiply by 10 only. So this is our first equation, and if we multiply by 10, you know the decimal points shift to the right side. If you divide by 10, the decimal points shift to the left side. So these are some basics. Again, this is equation 2. Now subtracting 1 from 2. So 10x less x is equals to 4.77 minus 0.47. So 9x is equals to 4.3. is equals to 4.3 by 9, or x is equals to 43 by 90. So this is PQ. So hope you are getting, but still I will solve again. X is equals to 0.001. So since 3 digits are repeating, we will multiply it by 1000. So when you multiply by 1000, for 10 it will come here, for 20 your point will shift here, and for 0.30 it will shift here, and again 001, 001. Okay, so 1000x is equals to 1.001001. Now again subtract 1000x less x is equals to 1.001 less 0.001. So 999 x is equals to 1. X equals to 1 upon 999. P by Q. Q not equals to C. Now, if you keep on solving, it will be quite easy. Now, express 0.999 in the form of P by Q. Are you surprised by your answer? Why it is written that it is surprised by your answer? Okay, we will see. Take x is equal to 0.999 as a first equation. Only one number is repeating, 9. So, multiply by 10. This is your second equation. Now again subtract 1 from 2. 10x less x is equals to 9.99 less 0.99. 9x is equals to 9. X is equals to 1. Okay. So why this is surprising? Because 0.99999 it terminates to 1. If it's only 0.99, it will not 1. But if it goes to number of times, it will be very close to 1. This is what it shows in the example. That if there are if the point 9 repeats multiple times, then the values will be very close to 1. Now, what can the maximum number of digit be in the repeating long of the digit in the decimal expansion of 1 by 17? So ultimately you see 17. So what we have learned earlier, perform the division to check your answer. So we have performed the division also here. Okay, this is first one, this is second one, and this is the third one. I think yes. Now it will, the repeating string will be less than 17, that we know. How much it is, we don't know. So we keep on dividing 17 1, not we put point 0. Again it will not divide, we keep 0 0. 17 5 is 85. 15, we keep on dividing here and here. Then how many numbers have come? 0.05882352941170. So means up to 7. After 7 it starts repeating itself. So 1 2 3 4 5 6 7 8 9 10 11 12 13. We know that it is less than 17, but how much we don't know. So we have performed the calculation and found that 13 strings are repeating. 13 strings. So this is what's, so in exam you have to do it in one page and do it very carefully, because once you miss anything or miscalculate anything, you will not get the repeating string. So here I have done 9 from here, I've done here. 90, 85, 34, 65. The remainders are keep on changing. So this is 11. It comes here. There are 16 digit in the repeating block of the decimal expansion of 1 by 17. Now next question number 6. Look at several examples of rational number in the form of p by q, where p and q are integers with no common factors other than 1 and having terminating decimal representations. Can you guess what property q must satisfy? Okay. For a rational number in the form of p by q, where p and q have no common factors, the decimal expansion terminates only when the denominator q has no prime factor other than 2 and 5. Prime factors mean divided by 1 and itself. So we'll prove this, so that denominator q has no prime factor other than 2 and 5. If there are other prime factor than 2 and 5, then it will not be rational. So this will be the term for q is equals to 2 to the power m and 5 to the power n for some whole number m and n. Now example 1 by 2 is equal to 0.5. Denominator is 2. 3 by 5. This is terminating. You can see 3 by 5. Denominator is 5. It is terminating. Denominator is 5. 7 by 20. So 0.35 will be terminating. Denominator is 20. 20 you can write 2 to the power 2 into 5. It will be 4 into 5. 20. First you see the example, then you will understand what it is trying to say. But 1 by 3 is equal to 0.337 non-terminating. 1 by non-terminating. 1 by 7 is equal to 0.1422. This is also non-terminating because 3 and 7 are prime factor other than 2 and 5. So what was the question? Look at several examples of rational number in the form of p by q, where p and q are integers with no common factor other than 1 and having terminating decimal. He is asking the terminating decimal representation. So when it will be terminating, this is the property. When q is equal to 2 into 5 to the power 2 power m, means, let me understand, will be terminating only when denominator q has no prime factor other than 2 and 5. Okay, for any whole number. So this is the number you can write. Q is equals to 2 to the power m into 5 to the power n, because these are, there are only four prime numbers between 0 to 10. 2, 3, 5, 7. Okay, means this is divided by 1 and itself, only these four numbers. So q has no factor other than 2 by 2 and 5. Okay, you can see 2 and 5, because when the value of q will be 2 or 5 or in this form multiple of 2 and 5, then only it will be terminating, other than it will be non-terminating. These are our rationals, but question asks what property should q satisfy for the decimal to be terminating. So q must satisfy this equation, because if you go with 3 and 7, these are also prime numbers, it is non-terminating. Okay, I hope you what I'm trying to say. So out of four prime numbers, prime factors, only the value of q will, your decimal will terminate only when the value of q will be 2, 5 or multiple of 2 and 5. Write three numbers whose decimal expansion are non-terminating or non-recurring. Number whose decimal expansion are non-terminating, non-recurring are called irrational. So directly it is saying write three irrational numbers. You can write root 2, root 3, root 5. You know the value. So 1.4, 142, 1.73, 20508, 2.236, This is simple one. Now find three different irrational number between the rational number 5 by 7 and 9 by 11. So get the decimal expansion of 5 by 7. It's 714825. It is non-recurring and non-terminating and non-recurring. 9 by 11 will be 0.81. So three irrational numbers. You just write between. You can take any number. This is also a number, and it is greater than this and less than this. So 0.730, 73000, 73000, 73000. This is our non-terminating and non-repeating. Non-repeating in the sense it is 730. This is 270. This is 3 times 0. Similarly, you can write 0.750, 7500, 75000, 7.90. 0.81 you can write any number which is non-terminating and non-recurring. Classifying the following numbers as rational or irrational. Now you can see root 23. So 23 is not a perfect square. So root 23 cannot be written as a rational number. So root 23 is irrational. If you go on solving, it will not be non-terminate. The decimal will be non-terminating and non-recurring. The value of this one because it is not a perfect square. Now root 225. This is the perfect square. 15 square is 225. So if you solve this, this is the integer and it is a rational number. Now 0.3796. So there is no bar, nothing over this. This is terminating actually. So this decimal terminates. So according to our property, the decimal which terminates are rational. Now 0.478478. You can see that this part is repeating 0.478478. So this can be also written as 7.478 bar. But this is recurring, non-terminating by but recurring. So this is also a rational. Now 1.10, 100, 100. So this is non-recurring, but it also this is non-terminating, but it is also not recurring. No, no part of this uh, digit is recurring. This is 100. This is 100. This is 10. This is 100. 100. 4 times 0. So this is non-terminating and non-recurring. So irrational number. Okay. So I think there are only 9 questions are there. I hope you got the solution and you have some concept clear about the rational or irrational by looking at the decimal expansion, or you can do the decimal expansion and check whether it is rational or irrational. Just repeating last time, rational means it will be terminating or only two properties will be there. Either it will be terminating or non-terminating but recurring. For irrational, it will be non-terminating and non-recurring. So thank you. Thank you for watching. To like the video, subscribe the channel. In next video, I will check 1.4 is required or not because this is only representation of these digits on number line. That is very easy. I'll just show you one or two example. Then go to chapter 1.5. Okay, then enjoy your holiday, summer holidays. Keep studying. Ninth is not like the other classes. Up to 8, it is very much different, but from ninth, you have to work hard because 10th is also not tough, but ninth is more tougher than 10th. You have to study maths, science, social science, histories, civics, geography, physics, chemistry, biology. Biology is very lengthy. Ninth biology. So nothing to worry. Utilize your time properly. Give your time. Give each subject some time. Don't spare anyone. That this is easy one because only 1 month is only gone. Only 11 months are remaining. Lots of syllabus are there. So all the best to everyone. Thank you. Keep shining. Bye bye.